failing in both papers is now here the two events A and B denoted by the student failed in paper 1 and paper 2 respectively. Okay, solution. Let A comma B be the events denote that the student failed in paper 1, paper 2 respectively, respectively. Then from this assumption AB failed in paper 1, paper 2, what are the given? P of A is equal to 0.3 comma P of B is equal to 0.2, and given that whatever the sentence given, that is going to denominator according to previous conditional probability. Student has failed in paper 2 given. Paper 2 we have denoted by B. That means B goes to denominator. The probability of failing in paper 1. Paper 1 we denoted by A. So this is the conditional probability of A given B is equal to 0.6. And what we have to find? The probability of a student failing in both papers. Both means in the last class I have given some verbal descriptive sentences against that equivalent set theory notation. Both A comma B means A intersection B. At least one of A comma B means A union B. Okay, exactly one of A comma B. I have shown you Venn diagram also, only A, only B. That is called verbal descriptive event and equivalent set theory notation. So both papers means what we have to find? Probability of A intersection B, question mark. Solution. See, because we know that this is P of A intersection B divided by P of B. I can write that is P of A given B. From this, P of A intersection B is equal to P of A given B into P of B. Just cross multiplying. Substitute the above data here. P of A given B is 0.6. P of B is 0.2. This simplifies to 0.12. This is the answer. The same here what I wrote the statement, this is also called multiplication theorem on probability or compound theorem of probability. Okay? Isn't it? The next one is multiplication theorem. This is also called compound theorem of probability. Just this is nothing but came by conditional probability only. If A comma B be two events of a sample space S, then P of intersection B is equal to P of A into P of B given A, or P of A intersection B is equal to P of B into P of A given B. Say here two events A and B. You start with whatever you like. If I start with A, the next, that means here first we are finding the probability of A. Automatically what is left in this? B. That means we are going to find the probability of B. That means here B is going to happen second. A is already happened. So that is multiplied by conditional probability B given A. Suppose if B is happened first, then you write P of B. So out of A, B already happened. Now which is going to next happen? A. So that is the conditional probability P of A given B. These two results came by the definition and formula of P of A given B and P of B given A. Look at that and just bring the denominators into other side. You will get these two results. These two came by the conditional probability formulas only. Okay. So the above example what I have done in 2007 came by this theorem only. Next, I am giving the same theorem for three events, any number of events. If A, B, C be any three events, then P of A intersection B intersection C, common part, probability. So here you, depending on the nature or the given, you start with, that means any one of these means either A or B or C. So each point, each element, each set, each event we are finding the probability. Suppose A has happened first, that means first term is probability of A. Next, which is going to happen randomly, okay, you take either B or C, but consecutively I am taking, okay. Suppose B is happened second, then already which is happened first? A. Whatever the things happened in the next step, you keep that in the denominator, okay. Next, A happened, B happened. What is going to find next? C. That means we are finding the probability of C. Already which are happened? AB. That is, AB is nothing but A intersection B. Don't by heart, okay. Just easy to remember. Whatever the given events, randomly you take any one of these first happened, then write its probability. Next you take in the remaining second is any of one of the happened, then find the probability of second, and in that put the denominator already happened previously. In the third step, randomly in the remaining take any event, third event, find its probability in the corresponding denominator. Already what happened previously, put in that denominator. Okay, this is extension to n events, anything. So based on conditional probability, I am giving one problem. Later you check. I will give the answer also. You check later. This problem tells, this problem is an example of conditional probability, okay, conditional events problem only. Let A and B be events. So this problem not related to this theorem, just I am giving base previously what we have discussed the conditional probability, using that I am giving the problem. With P of A is equal to 3 by 8, comma, P of B is equal to 5 by 8, and P of A union B is equal to 3 by 4, find P of A given B dash. Answer I am giving, later you check. Answer is 1 by 3, 1 upon 3. I am giving hint, the formula using conditional probability definition. This is probability of intersection of the two events, that is A, B dash, divided by denominator event probability. Here B dash, we know that last class we have discussed B of not happened means 1 minus P of happened. That is P of B dash is equal to 1 minus P of B. And A intersection B dash is nothing but only A. That formula also I have given in the last class. P of A intersection B dash is equal to P of A minus P of A intersection B. Using that you will get 1 by 3 answer. And you remember not only these two but also P of A union B, addition theorem of probability. That is P of A plus P of B minus P of A intersection B. Next. So let me do one by one definition, results and examples, gate questions. After the completion of all the definitions, we will do some more problems based on this. Okay? Next. Independent and dependent event. If the occurrence of the event B is not affected by the occurrence or non-occurrence of the event A. See, here A, B are two events. If the occurrence of the event B is not affected by the occurrence or non-occurrence of the event A has, that is, here B is not affected by the event A has happened or occurred or non-occurred. Okay. Then A and B are called independent events. Otherwise, A and B are dependent. See, or you can write instead of this sentence, then because we have started with occurrence of the event B. B is said to be independent of A, otherwise B is dependent of A. In this case, we say that A and B are independent events. See, suppose, let me explain two examples. In a pack of 52 cards, a king card is drawn and not to be replaced in the pack. That is, take a king card and keep outside. Then the effect of this drawing, so that is this drawing is does affect the another king card to be taken from the remaining cards. Okay, that means if a king card is drawn not to be replaced, then this event does affect the drawing of the second card. Correct or not? That means the king, because we have replaced, not to be replaced, that means we have kept outside first king card. So drawing a second card, that means the first already drawn card, the king card, will definitely will depend on the drawing of second card from the remaining pack of cards. In that case, the two drawings are called dependent events. Next, A and B, that is, a man and woman appear in an interview for two vacancies in the same post. The probability of a man's selection is 1/3 and the woman's selection is 2/5, etc. Okay, in such cases they are appearing independently, they are trying, that is, they are going for interview independently. In that cases, man and woman are called independent events. Okay, that means strictly speaking, not to be replaced tells that dependent events, if the event is replaced, that is, suppose two cards are drawn one at a time without replacing, that is called independent. That is called dependent. Two cards taking one at a time with replacement, such type of problems are called independent. Okay, like that. Note, this is very important point. If A and B, very important, independent events, then the following results are true. 1, that is the conditional probability A given B. Actually, the conditional probability A given B means the numerator depends on denominator. Generally, in the numbers also, which is dependent on other numerator quantity is always dependent on the denominator only. Okay, so whenever the events are independent, then probability of conditional becomes probability of numerator only, that is P of A, and probability of B given A is equal to probability of B. Second result, this is very important. Probability of A intersection B is equal to probability of A into probability of B. Third result, A comma B dash, A dash comma B, A dash comma B dash are also independent. then this conditional probability becomes numerator only. In this also becomes numerator only. And the probability of intersection, multiplication theorem becomes product of their probabilities. Okay? Because of A and B are independent. So whenever A, B are independent, A, B dash are also independent, A dash, B are also independent, A dash, B dash are also independent. Please remember these 3 points based on independent events definition, very, very important. Okay? So once again I am telling, if a king card is drawn from a pack of 52 cards and not replaced, the result of this drawing does affect the drawing of second pack, whatever it may be, okay, in the remaining cards. And these 2 cards of drawing are called dependent events. Okay, I have already explained a man and woman interview, independently they are trying. Suppose 4 people trying hitting a target by gun or whatever it may be, okay. So that 4 people trying independently, that in that cases the problems are independent events. And some problems you take care about the word. If it is not replaced, that is called independent events. That is not replaced, that is called dependent events. If it is replaced, okay, that is called replacement, means independent events. Not replacement means dependent events. Okay. One. This is given 2007. 2 cards are drawn at random in succession, comma, with replacement, comma, from a pack of 52 well shuffled cards, probability of getting both aces is solution. Here 2 cards in succession, that is one by one taking 2 cards. The 2 cards compulsory should be aces. From a pack of 52 cards, there are 4 aces. 2 cards are one by one picking with replacement. So first card can be happen in 52C one ways and replace again it. So total number of again 52 cards. Again second card is also getting in 52C one ways. Of these 2 cards, it is mentioned 2 aces. Okay. Let E1, E2 be the events, denote that first card, comma, second card are aces. Okay. Then what we have to find? Both are aces. That is P of E1 intersection E2. The meaning of this is both aces. According to set theory, both. Okay. So because I told you with replacement means that is independent events. Without replacement means dependent events. And just now I gave a formula. Whenever A, B are independent, probability of A intersection B is equal to product of their probabilities. So this can be written as P of E1 into P of E2. So probability of first chord is yes is 4C1 by 2C1. Because of replaced again in the pack, then again total chords is 52 and 4 ace chords. So second chord to be ace is again 4C1 by 52C1. Since first king chord, first ace chord is replaced. That is the reason. And E1 comma E2 are independent. As the two chords drawn in succession with replacement. This is the reason which is available in the question also. Because the product of the probabilities is independent as the two chords drawn in succession with replacement. So here why we got again 4C1, first chord is replaced. So this simplifies to 1 by 169. 52C1 52, 52 4, 4 by 52 means 1 by 13 and 1 by 13, 1 by 169. Next. Another problem I am going to do. A box contain 6 red balls and 4 green balls, full stop, comma, 1 ball is randomly picked and then a second ball is picked without replacement of the first ball full stop. The probability that PROB probability both the balls are green is so here also total ball 6 plus 4 10, but one ball is picked without replacement of the one ball is randomly picked and then a second ball is picked without replacement, okay, of the first ball. So without replacement, I told you it is an example of dependent events. So here also let E1 E2 be denote that the drawing of that the drawing of first ball, comma, second ball, are green. Then what is the question asked? Probability of both are green. So this is both green. So because of without replacement, this is using multiplication theorem of probability, compound theorem of probability, P of E1 into P of E2 given E1. What is the meaning of this sentence? Probability of first drawing ball to be green and it is kept outside, that is without replacement. E2 gives drawing a second green ball if the first green ball is happened already, we kept outside. So what is the probability of first drawing a green ball is 4 C1 out of total ball, that is 10 C1. Because it is replaced outside without replacement, then the total number of balls in the remaining balls in the bag is 9. The second ball can be picked in 9 C1 ways. That second ball is also asked 4 green balls. Already one green ball we kept outside, so there are remaining 3 green balls. One green ball from the remaining 3 green balls is happened in 3 C1 ways. So 4 by 10 into 3 by 9. So 3 ones, 3 threes, 2 ones, that is 2 by 50. So here I used dependent events means multiplication theorem of properties. Second ball is drawn without replacement of the first ball in the box, and total balls is equal to 6 plus 4 is equal to 10. 6 red balls, 4 green. R stands for red, G stands for green. That is the reason. So let me see one more problem. Any there? 2010. A box contains three red and 2 black balls, full stop. 4 balls are removed from the box one by one without replacement. Here also you can write the reason E1, E2 are dependent events. In the last problem we add this sentence also as a reason. The probability of the ball remaining in the box being red, comma, is. See, solution here, total balls is equal to 3 red plus 2 black is equal to 5 balls. Okay. Probability of 4 balls, just I am giving one line sentence. Probability that the ball remaining in the box being red is nothing but probability of drawing or removing 2 red and 2 black balls in the box, because 4 balls are removed. Since 4 balls are removed from the box one by one without replacement. See, total balls 5. 4 balls are removed. That means compulsory 1 ball remained in the box. That 1 ball remaining ball should be, the remaining 1 ball should be red means, that means they are picking or drawing or removing from the 5 balls 2 red balls and 2 black balls only. Okay. So, drawing 2 red balls and 2 black balls is nothing but the remaining ball is red, because 3 red balls are there. Here 3 red and 2 black balls. Okay. So, 2 red balls from 3 red balls can be happened in 3C2, and that means multiply 2 black balls from 2 black balls can be happened in 2C2, divide by 4 balls already taken. Okay, that 4 balls are already removed from the box containing total 5 balls, happened in 5C4 ways. So 3C2 means 3, 2C2 means 1, 5C4 means 5. Answer is 3 by 5. So total 5 balls, 3 red balls and 2 black balls. So what is the question asked? In the remaining ball in the box or bag should be red. That means how many balls drawn? It is given 4 balls. In that 4 balls, what are the compulsory? 2 red balls and 2 black balls. Why? Out of 3 red balls, the question is already asked, remaining ball is red. There are 3 red balls and 2 black balls. The probability is asking remaining ball is red. That means drawing or removing 2 red balls. Because of 4 balls removed, 2 red balls and 2 black balls only. That is. and this is 2006, 2 marks. There are 25 calculators in a box, full stop. 2 of them are defective, full stop. Suppose 5 calculators are randomly picked for inspection, that is, each has the same chance of being selected, full stop. What is the probability that only one of the defective calculators will be included in the inspection? So for this you try it. I am giving the answer for this problem 1/3. I am giving the hint: 25 calculators. 2 calculators are defective. Automatically remaining 23 are non-defective. Okay. But how many calculators randomly inspected? 5 calculators. So 5 calculators from 25 calculators can be selected in 25 C5 ways. That is your sample space total outcomes, N of S. In that 5 randomly picked calculators, one of the defective calculators will be included. Only one. So out of 5, only one defective means remaining 4 should be non-defective. So 4 non-defective from 23 means 23C4. 1 defective from 5 defective means 5C1. So your numerator is 5C1 into 23C4. Denominator is 25C5. You please calculate. You will get 1/3 answer. Okay.